Hello, everyone. I prepared 3 improper integrals videos. This is the first one. In this video, I'm going to show you how to calculate an improper integral. The other video is on comparison test of improper integrals. Now, what is an improper integral? Let's remind ourselves. They are integrals over the infinite intervals. So, for example, you have this kind of integral to solve. So let's say this integral LL, so that if we name it, it will be easier for us to work on. We can write this integral as the limit r goes to the infinity from 2 to the r, ln x, x to the third, x to the power of 3 over 2 dx. Now, we need to consider this integral, and we need to solve this, then substitute the boundaries, then we take the limit. So let's consider this integral by itself first. Now, we can solve this integral by using the integral by parts. So integral by, let's remind ourselves what was integral by parts. That's a function that's dg, f dg. If an integral in this form, then we can, that is equal to f times g minus g times df. Okay, if we say f is ln x, then df will be dx over x. And dg in this case will be this part, that is dx over x, the power of 3 over 2. Or we can write this as x minus 3 over 2. Now, we need to take the integral of this by the rule of an integration. So that will be 1 over minus 3 over 2 plus 1, x minus 3 over 2 plus 1. So that will be, that is 2, 3 minus 3 plus 2 will give us minus 1. And then this is a 2 in the denominator. That denominator is the denominator of this rational number that will come up. So that will be minus 2. So this is just minus 1 over 2. So basically we have minus 2 root x. So now we can substitute all the information that we got here into this formula. So this I will be f times g. So this is f and this is g. That's f, that's g. So multiplication will give us this factor. Then minus integral minus 2 over root x. That is g. And then this is the df. Okay, now this is a constant. We can take it out. Minus minus will be plus. Then we have this. It needs to be integrated. So that it will be exactly the integration of this as we've done here. So we can just copy it down. That is minus 2 over root x. So eventually we have minus 2 ln x. That will be, since minus, we are taking minus 2 out, that will be plus, that the root x is here. Then L is the limit of the integral I with boundaries 2 to the r. So that's minus 2 is a constant, can go out. And we're putting the boundaries in, we have ln r plus 2 root r minus ln 2 plus 2 root 2. So this is a constant, nothing to do with the limit. So we only need to think about this limit. Let's solve this limit by itself and then substitute it back. Limit r goes to the infinity, so we can separate these two. And this limit we have now. Now, the logarithmic function grows asymptotically slower than algebraic functions. This limit goes to the 0. ln grows slower than root. This means that ln r grows slower than the root r as r goes to the infinity. If it goes slower, this is faster, then you're approaching to 0. And we know that 1 over root r is equal to 0. So this is 0 and that is 0. So the whole logarithmic part of this part is 0, but we have this part. Since we have, minus and minus, then we will have plus, which will give us this numbers. So that's root 2 ln 2, because root 2 over root 2 is basically root 2. That's root 2 ln 2 plus 2, and that is, as a number, is 3.8087. So this is how we solve. This is just one example how we solve the improper integrals. Thank you very much for listening.